So I was playing Scribble.io the other day because I don't have anything better to do these days, and I just realized something. So Scribble, as described here, a free online multiplayer drawing and guessing Pictionary game. Is that even a word? Or just a word guessing game, and it's addictive. So you basically have to guess what other people might be drawing until it's your turn. Then some random people online would judge you based on your drawing skills. Like for instance here. What is that? Dream. Oh great, you get the idea. Oh cool, now it's my turn to draw a fish. Okay, I can do that. Pretty easy. There's the head of the fish, the body, the tail. Okay, I'm gonna stop right there. So, you've guessed it, I realized I suck at this. But no worries, as programmers, the first step of solving a problem is running into one. And I think we just nailed this one. So, we have got a problem. Now with the VS Code open, let's think of a solution. Got it. Let's create a main.py file with Python as our language of choice because I'm lazy and why the heck not. Let's create an init function real quick and see if everything works. Voila, we have successfully printed something onto our screen. Now coming back to the real problem. So I've opened KolourPaint, which is a clone of MS Paint for Linux, but much better and open source. Let's start with trying to draw a line, the simplest it could get, and save it as an image.bmp file. There we have it, our first monochrome test subject, a scapegoat. Just a bunch of colored pixels surrounded by some white pixels. It does not get better than that. So what we're going to do now is to try to save the pixel values in a file where 1 represents the black pixels that we're actually going to draw and zeros representing the white ones. So the way this function works is we take an image, convert it into a monochrome image, store all the pixel values and iterate over them. If our pixel is black, we save it as 1 in our output and a 0 if it's a white pixel. Let's now try to run it and see what do we get. Error, oh yeah, I needed to import image from Python imaging library. There you go, rerun it and it executes successfully. Remember, this was our test image, and if we open the output file, we get exactly that. You can see we get 1s for black pixels, which when combined look very similar to our figure in test image. Now let's step it up a little bit and draw something more complex. Maybe make it a little bit smaller too, so it's easier to look at. Maybe we'll add a curvy line too in addition to a simple boring line. Or maybe we'll just stick to a circle for now. Oh yeah, that will do nicely. Now let's run our bot again, and whoa, isn't that cool how far we have come in technology? Anyways, all that's left to do now is to draw these ones instead of writing them to the file. We don't need this output path argument anymore. Now we do a manual check for our current pixel, and if it is not 255 or if it is not pied, we use the click function from PyAutoGUI to click on the corresponding X and Y value on screen. Easy peasy. Let's run it again. And it just keeps clicking on the corner of the screen. Well, we actually need to give ourselves some time to switch to the paint window to start clicking, where each click is a black pixel on the screen. Let's also print a user-friendly message on our terminal before that and run it again. Run it again, switch to the paint window, and in 3 seconds, it still seems to follow the same behavior of clicking on the corner of the screen. And I know exactly why. Let me just go ahead and kill the process real quick. Okay. Well, you see the X and Y arguments passed to the click function of PyAutoGUI are relative to your entire screen. So in order to actually start drawing from here, we need to add the X and Y starting values of this very point to our function. So basically just some start X and start Y values to avoid clicking on the screen. And I want to figure out a way to do that graphically instead of manually entering the coordinates for our starting position. So after some searching through the documentation, I came up with a solution from ChatGPT, and it's pretty neat. We have this function here that gives us the x and y values of the point that you select on the screen using the screen capture class it created. Then we get a list of star x and star y by calling this function. Let's run it again. Oh yeah, this class actually depends upon the py input package, so make sure you import that as well. And that is pretty much it. Let's rerun it, and the bot won't start working now until we actually click at a point on the screen to tell it to start drawing from there. Nothing's happening. Let's see what's going on here. Oh yeah, we forgot to pass it to our function star x, star y, rerun it. We actually don't need this time anymore. Starting in 3, 2, 1. There you go. It actually starts drawing. How cool. But it's way too slow. Let's fix that. So after reading through the docs, I found out that we can actually control the number of clicks per second by setting py_auto_GUI.pause to basically as fast and low as your CPU can handle it. Maybe just another 0. I believe in your CPU. Aww. So let's run it again in 3, 2, 1. Much faster. But that was just a very simple image. Let's change the test subject to what we actually faced as our problem in the first place. A freaking fish. Yeah, that'll do. Let me save it and rerun the board. 3, 2, 1. Okay, now that's way too slow. It took a total of 105 seconds, which is very impractical for what we intended for our scribble board. So the first thing that comes to my mind now is to just scale the test subject down, which we can achieve using the PIL library, because let's be honest, we're not going to draw full HD images with millions of pixels in them. We're just going to scale our images down to the size of canvas for scribble. Let's say it's 500 times 400 for now, and we pass the output of our scaled image as input to our init function. So let's rerun our board and see what happens. So it took a total of 45 seconds this time. But that is still too slow considering we're only dealing with one color for now. So how do we fix that? Here's the deal. If we observe closely, one click of our brush takes around, how many pixels are under there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 16 pixels almost. So that means we're basically clicking the same spot 15 times when we draw our image. And that is what we're gonna do. We are going to write some logic to skip a given number of pixels when drawing, and this is how we're going to achieve it. So in our init function, we're going to check for a counter variable and only going to reset it on a mouse click, and then click only when we hit a certain threshold of how many pixels are we planning to skip. So let's call it brush size and pass it to our init function. Rerun the board. 3, 2, 1. Much better. It only took a total of 12 seconds this time, which is not very bad. Let's try it again with a bigger brush. I think I like the previous one better. It's time to add colors now. Instead of black and white, let me search for a colorful fish now. Okay, definitely not what I meant. Yeah, that is what I'm talking about. Let's save it as our input image now. Now, in order to fill our images with color, we need to be able to do two things. First, we need to be able to select a color from the given colors tray, and then from our image get the closest matching color. Well, because our image is frankly more than just these given colors, let's start working on the second part first. We need to tell our program to recognize the given color palette and tell it specifically where to select each color from the tray. So we have got this color palette.png file saved inside the palette folder, and we will also create this JSON file to essentially describe this color palette. We will start with name or the exact relative path of the palette. Then we also need to do the width and height of the color palette to move our pointer relative to that. And then to move it to a specific cell, we need to also describe how many pixels does a single cell contain. There are 2 rows and 11 colors in each row. Then inside our data array, we actually describe each color. Each color inside this array is going to be an object, each having its own RGB value and a row and column index to tell the program how to locate it. So our first color is black, which is 000 on the 0th row and 0th column, and then we need to repeat that for all of the colors inside the list. And how do we do that? How do we know the RGB value for each color? Well, you can use any color picker available. I'm just going to use Chrome, and if I inspect it and set color for any color property using the color picker, I can get its RGB value. So just like that, we will populate our entire array. With that done now, we need this function to convert our given image into this specific list of colors so that it's available in our color palette. Now we need to define our custom colors in the program and pass them to the function. These are the same colors that we defined inside our JSON file. So let's first run the program only with this function to check if the image is actually converted or not. And this function returns an image, so we can save it like this to a file. And then we'll scale this converted image instead. So let's now run our program. Oh yeah, you also need to import NumPy for this color conversion, so make sure you do that. Let's run it again. And we get our file right here. And there you have it, an image made of only the colors that we defined and only the colors that we need. Now coming back to the first part, we now need a way to select a given color. So we will write this new select color from palette function, which will take in the palette and color to be selected. It will then locate the given palette on screen for given seconds. Let's also pass that to the function. And when it finds the color palette, it moves to that color in the palette using this logic right here, which is really simple. Let's break it down. All it's doing is searching for the given color in the JSON file, and when it finds one, it simply moves to that coordinates relative to our color palette. Let me show you how. So let me go ahead and run this function separately and try to locate the color palette on screen. Let's run it and switch to KolourPaint, and you can see our function has detected the palette on screen, and it returns its X and Y values. And it's really straightforward now. We just have to use some primitive math to move to that specific row and column. Let's say this light blue color in our color palette. And this is exactly what we did here in our function. So let's try to select that blue color from our function now, feed its RGB value to the function, and run our program. That's strange. It has selected a different color. Let's try selecting another color to see what is going on here. Let's say 255 for white and rerun it. I see what's going on here. So all we have to do now is to use an offset or a bias and add it to our calculated X and Y positions for our color here, since the palette itself has these borders around each color which are unclickable. So we will pass a new argument for bias and set a default value to 12 right there in the middle of each cell, and add the bias to our X and Y positions, and that should do it. You can see we have successfully selected the white color from our tray. Let's try it again with our blue color, and success. Wonderful. All that's left to do now is to draw our test subject on this paint window using the colors of need. So let's do that now. We need to make a few changes to our init function. First of all, instead of just clicking individual pixels, we need to first select the color of the pixel, which is actually a tuple, so we need to convert it into a list. Then we load our color palette above here, and lastly also remove this monochrome conversion. Now it would be very costly for us to select the color each time we add a new pixel to the screen. We only need to change the color from the palette when there is actually a new color to draw. And for that reason we're actually using the temp variable here to only select a new color. Now let's rerun our code in 3, 2, 1. Let me change this brush size, and it has started drawing. How cool is that? Let us wait for it to finish now. Okay, I can do this. It is painstakingly slow and it's not selecting proper colors. Let me see what's going on here. So this is a converted image that we need to draw as opposed to the colors we're getting from our program. So after a bit of debugging, I found out what was causing it. We are actually scaling the image after conversion. Damn, how dumb. And scaling it down just adds a bunch of arbitrary pixel values to our image. So we need to first scale the image and then do the conversion. Make a few adjustments here and run it again. We can see it does select a new color every now and then, but that is still too slow to be of use. And I can actually think of a solution to that. How about we divide our test subject into our 22 different colors from our color palette, and then basically just draw each color on the screen. This way it will only select a new color per image, which is going to make our code much faster. So I took a little help from ChatGPT into writing such a function for us, which would split our image into different colored images. And I'm going to test this function now on our converted image. You can see in this folder we get exactly what we need. Now we just need to iterate over this list of images and draw each one separately. So in our split colors function, instead of writing the images to a file, we'll pass them to our very own init function, make some minor adjustments here and there, and then call this split colors function in our main. So let's run the bot again. Oh yeah, keyword args go to the end. Anyways, let's restart it. And it works hopefully.
Oh yes, finally.
That is much better. In fact, the best one so far. And the whole process took about 40 seconds, which is bearable, I guess. And yeah, I also tried some other clicking libraries and the results were about the same. Anyways, coming back to Scribble.io, let us do a configuration speedrun and set our board for Scribble. Let's rerun our board now with this test subject and scale our image to fit the canvas size of Scribble.io. Damn it, I keep forgetting. 766 times 574. Maybe a little bit less than that. Run it again and wait for our signal. It's time. One last thing that is left to do now is to download our input image of choice programmatically, so we don't have to Google it each time. And I think I might just have it on one of my repos when I designed the Instagram command bot. Link to that in the card section of this video if you want to watch it. And this is the command function that we're looking for. Turns out I had pushed the API keys as well, which is the cherry on top, so we won't have to get a new one. But if you're watching this video, this API key has probably been revoked, so just get one of your own. Seriously, it's free. Link in description. With that in mind, let's test this code and see if it still gets our image of Super Mario from prompt. Which it does. Not a bad result. Let me run it again. Okay, I can assure you this is not Super Mario. I mean, who is this guy? Run it again, and we get a different image. Cool. But let's make a few changes. First and foremost, instead of returning a random image from results, we're going to get the first one, because it is always the most related. Let's now search for a cat. This is what we're looking for. Let's wrap it up into a function which also downloads this image as our input image. For that we need the requests package. Make sure you install it first. Let's try downloading a Superman sketch and see. Okay, how cool. This would be super easy for us to draw too. Only thing that's left to do now is to download the image as our input image. And yeah, another last thing that's really important is a way to tell our program what to draw when we choose a word. We can do that easily using PyAutoGUI's text box here. Test it again, and we have got this cool little prompt box. Give me YouTube, and there you go, YouTube guys, or something. Time to test it in the real world. Okay, we have one more person until we draw. Is that a fry pan? Oh no, a well. Yes, damn it, an omelette. Pepper, jalapeno, I don't know, I give up. Looks like this person needs the boat more than I do. Oh, it was an ashtray. Makes sense now. Not bad, not bad. What, more people? Okay, we can wait. Oh yeah, it's finally going to be our turn. Yes, yes.
No!
The Wi-Fi is down again. Yep, definitely down. Don't worry, let's just cut to the chase. So I made a few adjustments here, such as the bot now draws the black pixels first, so the image is easily recognizable while it's drawing. Also, I have reduced the scale factor to reduce the time it takes to draw, and added the keyword clip art and white background to search, which brings back the best images. So I hope you had fun. Subscribe for more videos, and the code can actually be found in the description below. So please also like the video if you learned something new today. Okay, goodbye. Goodbye. Take care. Seriously, you need to go now. I love you.